If you knock on a wooden desk, it resists your hand. But if you plunge down to the microscopic level, that physical solidity vanishes into an abstract, nebulous void. Think back to your middle school science class. You likely drew an atom as a tiny nucleus surrounded by electrons spinning on neat circular tracks, closely resembling planets orbiting the sun. That solar system model is completely wrong. It is a simplified fiction designed to make the mechanics of the universe easier to digest. For centuries, classical physics operated on a strict intuitive rule. If an object was matter, it was a solid particle with a specific location that you could catch. If it was light, it was a wave that rippled and interfered with other waves. The rules of classical physics fail at the subatomic level. To understand the true building blocks of reality, we must abandon our everyday intuition and accept that particles behave as waves. In 1924, Louis de Broglie, a French prince and physicist, proposed that every moving physical object possesses a wavelength. A wavelength is simply the distance between the successive crests of a wave. This animated equation shows his mathematical proof. Wavelength is inversely determined by an object's mass and velocity. In this formula, the letter h represents Planck's constant, which is a fixed microscopic value in physics. This diagram also shows why you do not see other people physically ripple out of existence when they run. Because a human's mass is so extremely large, the resulting wavelength shrinks down to a completely undetectable flat line. As this diagram shifts to represent an electron, the math flips entirely. An electron's mass is so unimaginably tiny that its wavy nature dominates its physical existence. Drop down to the absolute smallest scales of the universe, and the concept of solid matter ceases to exist. It is replaced entirely by humming frequencies. Treating physical matter as a wave creates an immediate logical problem. You can point to a marble and state its exact static location, but you cannot point to a single exact spot on a spreading ripple in a pond. Werner Heisenberg, a German theoretical physicist, realized that this wavy reality prevents us from accurately measuring the universe. He formulated the uncertainty principle. This principle dictates that it is physically impossible to know both the exact position and the exact momentum of a subatomic particle at the same time. This uncertainty is not caused by weak microscopes or human error. The universe enforces a literal boundary on measurement. The closer we look to pinpoint an electron, the faster it escapes our view. Any observer is locked in a cosmic game of catch me if he can, where achieving absolute certainty is mathematically and physically impossible. Because planetary tracks around a nucleus cannot exist under these rules, physicists built a new model, replacing rigid orbits with defined spatial zones called orbitals. An orbital is not a physical pathway. It is a probability cloud, a ghostly three-dimensional region where an electron is mathematically likely to exist at any given moment. This 3D representation shows the shapes of these probability zones. S orbitals form spherical clouds, and p orbitals look like dumbbells. The visual shifts to complex d orbitals, shaped like four-leaf clovers. Inside these boundaries, there is a 90% chance of finding the electron. Outside, it is a ghost. A true atom does not operate like mechanical clockwork. It is a vibrating collection of localized probabilities and standing waves. This introduces the observer effect, a phenomenon where the simple act of measuring these ghostly electrons forces them to pick a single state and change their behavior. Just look down at your own hand. You are looking at a trillion overlapping waves, all held together by invisible electrical force. Because electrons exist as these sprawling waves, they can perform quantum tunneling. Quantum tunneling is a process where subatomic particles bypass classical physics and essentially leak straight through solid physical barriers. This impossible leaking effect happens constantly in the real world. It is the precise mechanical process that allows the flash memory inside your smartphone to trap electrons and store data. Human beings themselves, our immediate physical environment, and our modern digital tools are constructed entirely out of probablys, maybes, and inherent uncertainty.